Hello, let us look at the review questions from number 41 and up. Okay, let's get started here. So here we have f of x is equal to 4 minus x squared, and we need to evaluate f of negative 2. That basically means this negative 2 has to be in place of x. Then, basically I'm plugging in, as you can see over here. So negative 2 squared becomes 4. So this becomes 4 minus 4. Then we know that the answer is equal to 0. Alright, now let's look at the next question here. We need to identify if each function is a linear, meaning line, constant, meaning horizontal line, absolute value, which means v-shaped one, or quadratic. We know that as a parabola. Now, and then after that we have to see if they're a one-to-one function, meaning for one value of x, there's one value of y, and one value of y, and there's one value of x as well. And whether or not they're onto function. Now, just to simplify the concept of onto function, technically the definition of onto function would have been if the range has been all covered, meaning all values of the range has the corresponding value in domain as well. Now, but in our case, what we're going to be looking at is assuming that all the range for all real numbers of y are covered or not. That's basically what we're going to test upon. So we're going to explain further as we're going along. Number 42, we realize that this is equal to line because x and y are linear. Now when you divide by 4, you can see that much better here. Then we get to realize that y is equal to 3 over 4x minus plus 10 over 4. Now, so if you had to sketch this one, the graph would have looked something like this. Then as you can see, it's a line, so therefore it's a linear function. Now, is this a one-to-one function? Yes, it is, because for one value of x, there's one value of y. Wherever you look at, you will see that as well. So it's going to be a one-to-one function. But how about, is this an onto function? To see if something is an onto function, all elements from the range has its corresponding value from the domain. Now, then in this particular case, we're going to assume that the range which we're going to set up is the all real numbers. Now, if the function is a linear function, do we end up covering all real numbers from negative infinity to positive infinity? I'm talking about y values. Wherever the function is, you can see that for every y value has been covered throughout that line. So therefore we know that this is a onto function. Alright, now then let's look at the second one. Number 43, we have y squared. You see, since the highest exponent is squared, then we can say this is a quadratic. But it's not necessarily a function, but it's a quadratic. It will give us the parabola shape. But as you can see, when y has been squared, then it's not going to be a function in terms of x. So therefore, we don't have to worry about, it cannot be a one-to-one function, nor onto function either, because it's not a function, period. Now, how about the next one? Number 44. X equals 5. How does the x equals 5 look like? I think best way is if you have to sketch that, it would be best for us to analyze this one. X equals 5 is in fact vertical line, as you can see. Now, since it's a vertical line, it's a constant, but it's not a constant function. It's simply a constant relation. It's not a function in this case. And then, therefore, it's not going to be a one-to-one function. It's not going to be a function, period. So we'll stop here. Number 45. Alright, so when you look at y equals 10, we realize that that's a horizontal line. But the horizontal, in case of horizontal line, Is this a function? Yes, it is. In fact, this is a constant function. Then next question which we have to ask ourselves is this one-to-one? But not one-to-one, because imagine whatever the value of x would have been, the y value is 10, because y is always equal to 10. And if I pick another value of x, y value still will be 10 as well. So one y value has many x values, so it's not a one-to-one function. And given for the range to be the all real number, only value this function is covering is the y equals 10. So therefore, there are many values that's not covered, hence it's not a onto function. Alright, so let's look at number 46. How about y equals absolute value of 2x minus 3? If you have to use your calculator and sketch it, it might be a bit easier for you to look at. So if you have sketched this function, it will look like something like this, V shape. And then the turning point, as you can see on the bottom, is in fact equal to 3 over 2. That's the value that makes expression within the inequality equal to 0. Now, then this is absolute value function. As you can see, it looks like a V shape as well. But is this one-to-one? No, it's not one-to-one, because there are values, y values, that has more than one x values, as you can see right over here or over there. Now, but is this an onto function? Given that, then what we are looking for is are all the y values covered? Now, not all y values are covered. For example, there's no y values in the negative section anyway. So therefore, it cannot be a onto function in this case. Number 47. Y equals x squared minus x. So if you have to sketch this one, you will see something like this, where x-intercept is negative 2 and 3, and then y-intercept is negative 6. Then, yes, it's a quadratic because we see a parabola, and then highest exponent is 2. But it's not a one-to-one function because one value of y has more than one value of x. But is it onto function? No, it's not an onto function because you see the values up here are all covered. The value of y are all covered here. Value of y is not covered in the bottom. So therefore, it's not an onto function. Alright, let's look at number 48. Determine the largest possible domain. So, in case of a fraction, you cannot have the denominator equal to 0. Because when the denominators are equal to 0, the function is not defined. So, what we're looking for is we are looking for the values of x that's not allowed in the denominator. So, we are setting that not to be equal to 0. Then, just like any other quadratic, we will factor them. As you can see right over here, so negative 5 and then 4 will be used because they multiply to negative 20 but add up to negative 1. They're not equal to 0. That means our answer will be 5 and negative 4. So x basically cannot equal to 5 and negative 4. Then our domain will be values of x such that x is not equal to 5 or negative 4, while x is the part of all real number. Alright, let's look at second one, part B. Within the radical, the values of x has to be greater than or equal to 0. So therefore, what we are looking for is 2x minus 5 has to be greater than or equal to 0. Then you can see that 2x has to be greater than or equal to 5. As you divide by 2, then x has to be greater than 5 over 2, or greater than or equal to 5 over 2. So therefore our domain is set of the values of x such that x has to be greater than or equal to 5 over 2. Alright, how about the third one? Did you see that third one, part C, also has radical as well? So first instinct is to say that, hey, the values of inside of values of inside of the radical has to be greater than or equal to 0, but it cannot be equal to 0 because the denominator can never be equal to 0. So we can simply say that 3x minus 15 has to be greater than 0. Now, once I have done that, then 3x has to be greater than 15. As you divide by 3, x will be greater than 5. So if you put this one into domain, we'll get something like this. Alright, so those are our 3 domains. Alright, let's look at the next question. Number 49, we're looking at composition of functions. So, for example, for the first one, part A, one is plugged in the function g, and then the result will be plugged in function f. So in order for us to get a, f of g of 1, I'm going to try to calculate g of 1 first on the side. So negative 3x, instead of x, I have 1 and plus 1. Then that seems to be negative 2. So f of g of 1 now turns into f of negative 2. Actually, I'll be fixing this one a bit later. I forgot the negative sign. We'll come back to A very soon. Let's look at part B. When you look at part B, I'm plugging 1 in function f. And then with the results, we're going to put into function g. So once you plug in 1 in place of f, we'll end up getting 2 times square root of 4, which is equal to 4. Now, then g of f of 1 becomes g of 4 because f of 1 is equal to 4. Then plugging in 4 in place of x, then we get to realize that our answer is negative 12 plus 1, which becomes negative 11. Now, how about part C? G of f of 6. Then when you plug in 6 in place of f, in the function of f, then we get to see something like this. Now, what is square root of 6 plus 3? That becomes 2 times square root of 9. And we know that this one to be equal to 6. So now our next step is to find g of 6. Now once you plug in 6 in place of x, we get to see the answer is negative 17. Now I'm going to just, we forgot about the negative sign on the part A. So if you have to plug in negative in place of x in the function f, we'll be able to get something like this. Now then, negative 2 plus 3 becomes 1. So now it becomes simply 2 radical 1, which is equal to 2. Alright, so with that, we finished number 49. Let's look at number 50. So here we are looking at the same thing, but we are composing the expression, entire expression, in place of x. So f of g of x, then that's same thing as f of the function g is x over x plus 3, so that's what we're going to substitute here. Now, that means you can place that in the function f. As you can see, that's exactly what we have done. Even though this is correct answer, if you want, we can simplify this one a bit further. So now this becomes 4x over x plus 3 over 1. To have the common denominator, we're going to multiply top and bottom by x plus 3 on the second fraction. Alright. Over here, we got to then once you calculate this one, x plus 3 is the same value. And 4x, and then as you distribute 3 to x plus 3, then we get 3x plus 9. That's basically what we end up getting. And when you combine together between 4x and then 3x, we'll end up getting 7x plus 9 over x plus 3. That's basically what we end up getting. How about number B? Now g is outside, f is inside. So that means we end up getting g of 4x plus 3. Alright, so then 4x plus 3 would be in place of x's in function g. So 4x plus 3 and 4x plus 3 plus 3, which became 4x plus 3, which is top was still the same. Denominator becomes 4x plus 6. Alright, and that's it. Let's look at number 51. Here we have, given that h of x is equal to negative x squared minus 2, and then the domain of x will be negative 3 through 3. Then what we can do is this. We want to find out the x minimum, or x maximum, is negative 3 and 3. So you can set up the window that way, or we just have to find out what's happening at the end as well. So if I were to sketch this one a little bit, negative x squared minus 2 would look something like this. Alright, so we are looking for the largest element, meaning in the largest y value, which happened to be at the vertex. And you know the y value in the vertex, since x equal to 0. Then we get to realize that that's equal to negative 2. So therefore, largest value in the range would be negative 2. Becomes our answer. Alright, let's look at the next question, number 52. So here we want to find the inverse. That means I need to switch x and y. So what I'm going to do is, first I'm going to rewrite the function using y. Alright, now to find the inverse, all we have to do is switch x and y. X equals this time. Alright, that's basically what we have so far. Now, but the thing is, even though that is the inverse, but what we want to do is we want to express y in terms of x. Now, in order for us to do that, I'm going to cross multiply them first. So 3x is equal to 7 minus 8y. Then I'm going to subtract 7 from both sides. Then we get 3x minus 7 equals negative 8y. Of course, to have y by itself, we need to divide both sides by negative 8. Now, that's basically what we end up getting. Now, the first, next question is this one-to-one? Now, there's a couple different ways of looking at a one-to-one function. First way would be graphically, and that's what I'm going to talk about in this video. When you look at the original function over here, you know that this in fact is a linear function with the slope of not negative 8 but negative 8 over 3. Because the entire thing is a ratio in front of x, that becomes our slope. So then, if I were to sketch that, it would have looked something like this. It's a linear function. If you remember from earlier question, when you have a function, linear function such as this one, this will always be a one-to-one function, because for every value of x, there's value of y, and every value of y, there's value of x. Or you can say it passes the vertical line test to be a function, and also a horizontal line test as well. Then it will be a one-to-one function. Alright. Alright, so now, for the next question is this: determine the domain and range of the given function. And then find the inverse of f of x. Now, to find the inverse, which we're going to do first, we have to get xy becomes yx. So then simply all we have to do is this: we just have to switch x and y value. Instead of having 1, 2, our new value will be 2, 1. That will be the inverse. And 3, 4 becomes 4, 3, so forth and so on. Simply switch the numbers. Now, is this a one-to-one function? That means when you look at the original function, does x repeat? 1, 3, 5, 7, no, they don't repeat, so that therefore it must be a function. But in order for it to be a one-to-one, we have to make sure the y doesn't repeat as well. Then we have 2, 4, 6, 8 as our y values, and they don't repeat, so therefore it is a one-to-one function. Now, but not only that, actually, we will be looking at domain and range as well. What's the domain of the original function? Domain is a set of the values that comes out, basically x value, which is 1, 3, 5, and 7. 1, 3, 5, and 7. Yes, domain doesn't always has to be inequality or continuous interval. In fact, it can be just a few values. And then how about the range? As you can see from the original function, y values are 2, 4, 6, 8. So 2, 4, 6, 8. Those are the values for our range. Alrighty, let's look at the next question. Number 54. You see, when they say varies directly, that's the important thing here. Now, when they say something varies directly, it's like we're looking at simple proportion. Just like when you work, more hourly wage you get. That can be a direct variation. Or more you travel by taxi, more you have to pay. Direct variation. But one way or the other, basically what we have to do is we have to set up the fractions to be equal to each other. So a and b were the values from the first condition, and then a prime and b prime were the values from the second condition. Their proportion, meaning their ratio, has to be the same. So in the first question, 3 and 9 are the values of the first case. And the second one is x, which we like to find out, but y was equal to 4.5. So this basically is how we can set up an equation for direct variation. Now simply we can cross multiply them. Then you get to see that 9x must be equal to 13.5. Then of course we're going to divide each side by 9 to get x equals 1.5. How about number 55? When two quantities varies inversely, then instead of set the two conditions as a fractions, but we have to set them as a product. So a times b is equal to a prime times b prime. Then what are the set of the first values? 5 and 9. So then 5 times 9 has to be equal to x, which we like to find out, and y value is 20. Alrighty. So then in this case, 45 is equal to 20x. The value of x, when you divide by 20, x will be equal to 9 over 4. Now, next one would have been, they want us to sketch this one. Then I like to solve for y by itself first. Then y is equal to negative 18 over x. Alright, so if you have to put this one into a calculator and then try to get the values around 0 from your table, you would have gotten values similar to this one. X and y, when x equals negative 3 and then negative 2. For example, when x was equal to negative 3, then y value was equal to 6. And when x value was equal to negative 2, y value was 9. And so forth and so on. But when you plug in 0 in place of x, it will probably say error, and then we'll see about that graphically very soon. And 1 with negative 18, so forth and so on. And then if you had to look at your graphing calculator, the sketch would have been looks something like this. But all the values that we talked about here earlier will be placed in that sketch. So the first point could have been negative 3, comma 6, and second point negative 2, comma 9, and third point would have been negative 1, comma 18. And the same thing applies on the other side as well. 1 and negative 18. Alright. Now, but one thing that I want to realize here was that, as they say error, because about the values of x, what do we see? The graph doesn't pass through. Graph doesn't exist because this is a vertical asymptote. All right. Number 57. I like to highlight the word as you guys are reading this one. Directly proportional. That means, as you talked about with from number 54, you can see that we're going to set up a ratio. A over B is equal to A prime over B prime. Then what are the first set of values? 50 and then 2,000. So we're going to write them 50 over 2,000. And then second one is 80 people we know. We don't know the value here. So then when we cross multiply them, you get to see that 50x must be equal to 80 times 2,000. Alright, dividing each side by 50. X should be equal to 3,200 then. Alright, let's look at number 58. So first set of words which you have to underline will be inversely proportional. When they say inversely proportional, that means products are equal to each other, unlike the fraction. So then here we have A times B is equal to A prime times B prime. So first condition, values from the first condition is 6 and 30 seconds. So once you multiply them, it should be equal to the second condition, which is cavity will be values of x, and then 90. So then, as we divide each side by 90, you can see that the value of x would have been equal to now 2. Alright, let's look at the next question. Number 59. So we have absolute value inequality, equation rather. So then what we want to do is isolate the absolute value first, and then we're going to set up the two equations, one with the positive, one with the negative. Alright, that means I'm going to rewrite it as 4a plus 6, absolute value is equal to 4a minus 10 by adding 4a from both sides. Now, then first equation which we can write up is as it is. So we have 4a plus 6 is equal to 4a minus 10. Second one is one of the side has to be negated. So that's basically what we have. 4a plus 6 is equal to negative 4a plus 10. Negation of 4a minus 10. Alright, now from the first equation, when you subtract 4a from both sides, you are left with 6 is equal to negative 10. But 6 is not equal to negative 10, so therefore there's no solution. There's no solution from the first. Whoops. There's no solution from the first equation. How about the second one? By adding 4a from both sides and subtracting 6 as well, then this equation simplifies into 8a is equal to 4. So a is equal to 1/2. Seemingly I have an answer. But we cannot stop here because we have to check our answers. Once you plug in 1/2 in place of a, then you will see something quite interesting. Is equal to negative 10. Now, when you simplify the values inside, 4 times 1/2 becomes 2. So 2 plus 6 becomes 8. And minus 4 times 1/2 becomes 2 once again. So a minus 2 equals negative 10. And that is not the case. So therefore, the second value we found out, hopefully it was the answer, but it's not. So therefore, I'm just going to put it as an empty set, no answer. Alright, let's look at number 60 here. We have 4x minus 5 is equal to 3 with the absolute value. Then first, I'm going to set up two equations, as you can see. One with same as the original, except the absolute value sign. Second one has the negative sign right along with it. Now, from the first one, how would you find the value of x? This is rather simple because you add 5 from both sides. Then x will be equal to 2. And second case, we get to realize that x will be equal to 1/2. Now once again, let's not stop here, but let's check it just to make sure. So when you check the answer, we are plugging 2 in place of x's, or in place of x. So here we get 8 minus 5. In fact, is that equal to 3? Yes, it is. Second case is I'm plugging 1/2 in place of x as well. Then 4 times 1/2. And then, so once you, 4 times 1/2 is equal to 2. So 2 minus 5 is equal to negative 3. But the thing is, because of the absolute value, negative 3 becomes positive 3, therefore, which is equal to 3. Alright, so we finished number 60 as well. Let's look at a couple more questions. Number 61. We want to express everything using the positive exponent. That means the one that has negative exponent has to be shifted into from numerator to denominator, or from denominator to numerator, either way. Then first I'm just going to rewrite everything with the positive exponent. You see, first 2 was already there, and x to the negative 2 now went to the bottom, x squared. Y to the negative 2 went to y squared and then stayed in the denominator. On the other hand, y to the negative 5th power from the denominator, it should move up to the numerator. Then 2 and 4 cancels out, becomes 2. Y squared and the y to the 5th cancels out y to the 3rd power, but x squared stayed. Then we get y to the 3rd, and 2x squared becomes our final answer. Alright, let's look at number B. So one of the easiest things is to distribute this exponent, negative 2, in each term on the denominator, or each factor rather. Now, so once you do that, I'm going to copy down the top as it is, and then bottom one, instead of getting 2, we get 2 to the negative 2 power, x to the negative 6 power, or y to the 14th power. Now, if you have to start moving things around, we have 3 is already there. Y to the 4th power comes down, and then x to the 4th power comes down, while y to the 5th power stays in because it has a positive exponent. And then 2 to the negative 2 power has to come up, and it becomes 2 squared in the numerator. X to the 6th power moves up to be a numerator, and then lastly we have y to the 14th power. So once you simplify them, 3 times 2 squared becomes 12. X to the 4th and then x to the 6th power cancels out, becomes x squared. X to the 5th and then divided by y to the 14, in fact gives us y to the 9th power on the bottom. So we end up getting 12x squared over 9. Over y, rather. To the 9th power. Alright, let's look at number 62. Now, in order for you to express this one using radical or positive exponent, all we have to do is, since we see the negative sign, it's going to go down x to the 2/5 power. Now what does that mean? 5 on the denominator on the exponent means we are looking for 5th root. So here we get 5th root, and then x squared is on the still denominator. But we all have to be written in a way that it will be 1 over 5th root of x squared. And with that, we're going to close up for the review. I'll see you later. Good luck. Bye-bye.